Now class, we go to the example about the problem when you self set the register, when we don't set the register, when you write the program. Over here you have a small program and we want to input. Over here, now you use top33 to input a character. And if, of course, over here you don't check anything. But in future, if you have condition, you can write small session for checking if it's a digit or not. But over here, we assume that is a digit. Okay, so we use top33 and we change it to numbers. With the program, we declare some modification to store the value. Firstly, ask it to store MDO. That means minus 30. Count, storing 10. And binary, we use BLKW 10 to say we have an array of 10 values. Over here, we use BLKW to say we have an array of 10 elements. And firstly, we use LEAE, and we use the label binary, and we store it to R3 to say now R3 that point to the array of 10 elements. And ASCII, now we store the value from ASCII, that means minus 30 to R6, because in future over here when we have a digit over here, you want to get the value. And we load count to R7, so over here extension to the register R7. Because if you want to use R7 for storing the count, because we use count, okay, we want to use count and over here count 10. And we assign 10 to R7. And when we use to trap, you remember in the trap, so firstly we have to store, or we have to serve the register PC to R7. You know, over here when you load count value to R7, and over here what problem in trap. Over here you have small problem with this, okay, press tension. And the second, over here now, look at this. So what problem? Because you know we use top33, that means you want to get a character, okay? You know with top33 you have to use R0 to store the value you want in R0. And over here we have to change it to number, so we use add R0. Okay? And over here now in R0 that the value you want, okay, and we have to store it back to the element of the arrays, put it to by binary. Okay, and over here now we increase the pointer R3 to point to the new elements of the array, and then we decrease the value R7 to say, yeah, okay, we should read the value, okay, and then we now, okay, over here now we are R7 minus 1 to say, yeah, okay, now we decrease, I will check if it's not 0, so we go 2 again, okay, we can input the or letter, the or the digits, okay. Normally, when we use R7 to store the count, we have 10 times of doing, but over here is a small problem because we use log R7 count, no problem with this when we go to trap. And the second, because we use trap, that means we must use R0 to store the values to input. Okay, so by extension to this, so what do you think? What's wrong with this routine? What happens to R7 class? What do you think about that? So you know from the problem, you know you say you have two small problem from the call routine and from the calling routine, you know. Firstly, from the call routine or the call itself, extension, we before starting our call routine you must show on register that will be changed. Maybe in the subroutine, in the trap, in feature register subroutine you use the registers at that time, you can use it, of course, but before starting the subroutine or trap, you must serve on registers you can change. And before returning, please restore them. And the subproblem for calling routine. Okay, you must register destroyed by all instructions or by the call routine if values are needed later. For example, with the program over here, okay, you register R7, and in trap we use, and over here now we use, okay, so you must sell R7, you must sell R0. Okay, so over here now you have two questions for you. Can a subroutine call another subroutine? If so, is there any threshold the calling subroutine must do? So over here now, can you answer it for me? Okay, please answer this for your homework. Now we go to the next section in the chapter. That is subroutines. You know, trap, that's always routine, but when you write the program, maybe you want to write the subroutine for ourselves because you want to use it. Okay, so subroutine is a program fragment or session that lives in user's bed. That means you write it ourselves and it can perform a well-defined task, the function you want, and is invoked by another user program. That means when you want, we can use it. Okay, and extension, it can return control to the calling program when finished, of course. Like a subroutine, but not a part of the others, of course. That's our subroutine, okay? But it's not concerned with protecting hardware resources, okay? And if you want to use the subroutine, so you must use JSR, JSRR with this, okay? JSR, JSRR, jump to subroutine. Okay, jump to subroutine with the base register. Okay, and there of course is 0100, 0100. Of course, they're the same, but bit 11 is different. Over here now, if bit 11 is 1, we use BC of 11. Okay, to determine the address of the first function of our subroutine. But when we don't use, that means bit 11 0 at that time, we use the base register from bit 6 to bit 8. Of course, over here you use the base register. Okay, you must use it. Okay, so over here you have the reason when you want to use JSR for this. Okay, firstly, you must share the register BC to R7, and we check if it bit 11, 0 or 1. If it's 0, so we use the base register. But if it's 1, okay, you know, if it's 1, you use the BC of 11. Over here now you have the symbol in the part for GSR. Okay, first the same. Okay. And over here, of course. Now, because we use BC 11, so if you want to find the reference of a subroutine, so we can get from two factors to find the reference of our subroutine. Okay. And over here now it's different because we use the base register. Okay, of course, firstly you must serve the current PC to R7, and then we get the value from the base to set it to PC. Of course, over here, these are subroutines, so we must still return or jump R7. Restore the value from R7 to PC, and you must write this. But with 12, we don't need to write. And this is the structure of the subroutine. And then the structure at the end, we must use return. Over here, you must write label or the name of the subroutine. And you must show on the register to use the code for our subroutine. And over here, before return, you must restore the register you just used.